This is the board that we're gonna test today. It has 220 UF, 50 volt capacitor, filter capacitor on the rail, and this 2 wide capacitor is a 0.1 UF bypass with these two capacitors, and it also has the optional bell network here on the output parallel to the speaker, and a series inductor to the speaker. The input capacitor is this red one. I think it's a 1 UF. Let's see if we can zoom it in. That's a 1 UF capacitor. Looks like a fake Wima capacitor. So we're going to check if the IC used in this is fake IC. This one here, this one uses a fake IC, and it was only able to deliver around, I think, if I remember it correctly, 53 watts RMS on 8 ohms load. But this one is really cheap. It's around, I think, $3.50 plus shipping. But the price of this one is not too bad too. Around let's see the price of this one. Okay, so the price of this one is around $11.50 with free shipping. If this has a original IC, then I think this pretty good price, because the price of the IC alone, the genuine IC is price of the genuine IC from Moser is around $10 each. So if this contains a genuine IC, then this will be a decent price for this TDA7294 board. Look at the board, it's also nicely made. Looks very well done. This cheaper board with the fake IC is also not bad if you need a board with the built-in rectifier and filter. If you want a genuine IC, then you can just remove this and replace it with the genuine one. I have some quad 405 clone here. I also have a quad 606 clone here. I will be testing this clone board next. I tried using this power supply. It's a symmetrical 50 volts power supply, but it keeps shutting down. I think it doesn't have the juice to power up this this quad 606 at 4 ohms load. I got the amplifier hooked up to the heatsink. It's already hooked up to our 8 ohms load. Here it is. We have our signal gen here. We have our meter. And that's our room temperature, 14.4 C. This is our power supply here. It's set to plus or minus 40 volts. It's 40 volts. So we have about 80 volts from positive rail to the negative rail. I also have a fan here blowing directly to the heatsink. So that's the idle current here with no input to the amplifier, with the input set to 0. Now we're gonna check the maximum power output with 8 ohms load before clipping. I'm gonna also see its distortion. So that's clipping. As you can see, the top here is flat, so it's clipping. We're just gonna back it a little bit. So that's about the maximum output before clipping. It's around 73.6 volts peak to peak. This is our input signal here, 1 kilohertz. And this is our distortion here. We have the meter set to 0.1%. So that is 0.1 there. And so the meter is around pointing to 0.062%. So we're going to compute the RMS power output at 73.6 volt peak to peak, divide 2.28. squared divide 8, so that's about 84.6 watts. So that's 84.6 watts RMS at 8 ohms load. Now we're gonna test it with the 6 ohms load. I've now connected the amplifier to our 6 ohms resistor. Don't know if you can see that, 6 ohms. For the 6 ohms load, I have lowered the power supply voltage to around 36 volts. I want to set it to 35 volts, but the minimum the power supply can be set to is around 36 volts. So that's about our main supply with the amplifier. I got about 73 volts from rail to rail, from positive to the negative rail. Same last time, we're gonna check its maximum voltage output before clipping. Okay, so it's clipping at 66.4. So that is our maximum voltage output to peak at 6 ohms load, around 64.8 volts. Four point eight, 64.8. That's all distortion around 0.058. We just put the 0.06, 0.06%. It's not focusing. 0.06%. So we're gonna compute the RMS power. $64.8 divide 2.828 squared divide 6. So that's about 87.5 watts RMS. 87.5 watts RMS for 6 ohms load. Now we're gonna test it with the 4 ohms load. The amp is now up to the 4 ohms or to our 4 ohms resistor. Our power supply is still set to around 36 volts. 36.6. It's about 73 volts. I really want to set the power supply voltage to around 30 volts because the datasheet calls for around 29 volts plus or minus 29 volts, but I can only set this to around 36 volts, so that will be the voltage we'll be using for the 4 ohms load. Okay, so that's clipping. So that's about the maximum voltage output before clipping. 54 volts peak to peak with 4 ohms load. So that's 54 volts. We're gonna look at the distortion. So that's about 0.064%. Now we're gonna compute the RMS power. 54 volts by 2.828 squared divide 4. So that's about the RMS power at 4 ohms load, 91 watts RMS. So that's about it for the test for the TDA7294 amplifier. Power supply is pulling 178 watts from the AC source for an output of 91 watts RMS. The heatsink is very hot, that is with the very thick heatsink here, very chunky heatsink, and with the fan blowing directly over the heatsink. That's it for the test today. Please subscribe. See you next time.